amount of current flowing through it. So this inductor, it opposes the change in the amount of current flowing through it. And here the induction is defined as the ratio of flux linkage to the current flowing to the coil. And the unit for that is Henry, and the letter that used is capital H. So if I go for 1 Henry, if a current of 1 ampere flows through in the circuit and produces flux linkage of 1 Weber turn in it. Okay. So this indicated like this, L equal to phi I by I. So here phi is nothing but the flux linkage, and here this is the inductor, and this is the symbol of the inductor. So here we can observe this is the circuit where the inductor will be represented like this. So now coming to the inductor, and one more, I can also determine L is proportional to N square A by L. So here that is nothing but your inductance of the inductor. Inductor is the element and inductance is the property. It is directly proportional to the square of the number of turns. N is the number of turns, and A is the area of cross section, and it also directly proportional. L is directly proportional to the area of cross section and inversely proportional to length. So this is what the proportionality constant is indicated as mu, which is nothing but the permeability of the magnetic material. Now coming to the next one, that is capacitor. So this is also one of the basic element. Here the capacitor is the two-terminal electrical device which can store energy in the form of an electric charge. So in case of an inductor, it stores energy in the form of magnetic field or magnetic energy, and here the capacitor stores energy in the form of the electric field. So here if I consider how it can be indicated or how it can be constructed is, it consists of two electrical conductors which are separated by a particular distance. So here the space between these conductors may be filled by either vacuum or with an insulating material. So this insulating material is known as the dielectric. Okay. So the ability of the capacitor to store the charges is known as the capacitance. So the property of the capacitor is to store the electric charge when its plates are at different potentials. So for example, if q coulombs of charge is given to one of the plates of the capacitor, q coulombs of charge is given to one of the plates of a capacitor, and if a potential difference of V volt is applied between the two plates, then the capacitance will be represented as like this way, C equal to Q by V. So this is the capacitor where two plates are separated with a distance, and here these are the possible capacitors that are in a practical whatever that we are using nowadays. Now the unit for this capacitor is farad. 1 farad is nothing but if charge of 1 coulomb is required to establish a potential difference of 1 volt between its plates. So the capacitor is proportional to area and the distance between the plates. So it is directly proportional to the area of plates and inversely proportional to the distance between the plates. So this value of capacitance will be depends on the absolute. Here the proportionality constant is the epsilon. So which is nothing but the absolute permittivity of the medium between the plates. So this is about the base elements, resistor, capacitor and inductor. Now coming to, so these are the three elements and corresponding definition according to the Ohm's law. You can write down R equal to V by I and L equal to V by I and C equal to Q by V. And then coming to the current, I equal to V by R in case of the resistor, and in case of inductance, I of t equal to 1 by L 0 to t V dt, and capacitance is I equal to C dV by dt. So this is about the relations for resistance, capacitance, resistor, capacitor and inductor. and corresponding current and voltage relation. Now coming to the voltage, V equal to IR for the resistor, V equal to L into di by dt for the inductor, and V of t equal to 1 by C integral 0 to t I dt is for the capacitor. Now coming to the power or energy that is stored because of this resistor, inductor and capacitor, Vi is power expression for the resistor, I square R or equal to V square by R for the resistor also can be represented in terms of either current or in terms of the voltage. Now coming to the inductance, half Li square, and for the capacitance, half Cv square. Now coming to the sources. So here RLC are the passive elements, and the energy sources are nothing but the voltage source and current source. So this is the representation of voltage source, which is 16 volts, and this is the representation of current source, which is 4 amperes. So this arrow direction indicates the flow of direction of current, and this here the bigger one is positive and the smaller line is nothing but the negative. So here these are different types of sources which are dependent sources. So in case of independent, those values of the voltage or current will not depend on any other values or any element values. But here this voltage controlled voltage source, so here the voltage source depends on other voltage source. So and next one is current controlled voltage source, the voltage source which depends on other, which is controlled by other current source or other current value in a particular branch. Voltage controlled current source, so here the current source depends on the voltage across a particular terminal. And current controlled current source, here the current that is indicating depends on the current in through some other element. So these are the different types of sources, dependent sources. That means those values are not directly, but they are dependent on one another. Next one is interconnection of two or more sets. So for example, if you go for the circuit or the network can be a combination of different elements just like this way, but it may not require to have a closed path. But when coming to the electric circuit, which must have the closed path. So interconnection of two or more circuit elements with at least one single closed loop. So these are the basic elements which are required for our representation. So with this I will stop here.